So welcome. We're here at the moment, and we're just waiting for a few more people to start, and I'll make a few introductions once we've got some people on. Right. I'm going to go ahead and make some introductions. So, well, thank you everyone for joining today. We're really excited to have Anthony talk about this topic. It's really right in his sweet spot in terms of his expertise. And so Anthony's going to take a bit of time to talk about, how you can augment Elasticsearch and really reduce your overhead by using Scalyr. Anthony has a rich background in working within the Elastic space and is a well-recognized face and voice on the circuit. So we're delighted to have him speak. A couple of things as we go through it. Feel free to use the chat for any questions you may have during Anthony's presentation. We will probably get to them at the end when we can do some questions and answers. And if we don't get to them during the webinar, we will certainly reach back out and send them out to the attendees after the webinar. So without further ado, Anthony, I'd love to hand over to you, and thanks very much for doing this.
Awesome. Thanks, Neil, for introducing us. I will go ahead and kick us off. So today's topic, for those who may not have great glasses, is augmenting Elasticsearch and reducing overhead with Scalyr. And we will get our quick agenda. So our agenda is basically going to be introductions. I want to introduce myself, introduce Scalyr, introduce the Elastic technologies for some who may not be super familiar with them. We'll introduce a bit of the challenges. We'll introduce our solution specifically, and then like to drive it home to a conclusion. So first off, I want to introduce myself. Neil hopefully didn't take all my thunder, but my name is Anthony Johnson. I am the field CTO of Scalyr. I am relatively new to Scalyr. I've been about 6 to 8 months. I used to have a pretty wicked beard at one point. I was pretty proud of that one. It's a smug photo on purpose because everybody wants to look like Steve Jobs. And then that devolved into a pretty wicked mustache. And then 9 months of pandemic have left me a sad, shattered man with overgrown hair, no facial hair because my wife living with me for several months with no break. She's just like, I can't stand it anymore. But for who I am a human who loves sourdough and board games. I put human on there on purpose because I will make mistakes. If you see a mistake, I'd love to hear about it. That's how we get better, in my opinion, as people. I personally love speaking. So I have spoke at Elasticon, HashiConf, reInvent. I even spoke to about 7 people at the Minecraft fair in San Mateo. It was actually using Twitter into a Twitter feed and building a virtual village inside of Minecraft. It was kind of cool. Nobody saw it. I have won the AWS nonprofit hackathon at reInvent twice. That was me and my team. Pretty proud of that as far as in my career. Basically 24 hours, hack on something for a nonprofit and make it awesome. And then at the end of the day, I'm a human who knows where his towel is. For those of you who get it, awesome. For those of you who don't, read Hitchhiker's Guide to the Galaxy and it'll all make sense. So I work for this company called Scalyr. Scalyr is around 5 years old. It was founded by a couple of Steves, Steve Newman and Steven, I'm not going to try to pronounce his last name. And basically these guys are still with the company. They are still, they're the principal techs for the company. And their claim to fame is, they basically ran Google Drive. They wrote Google Drive. It was actually an acquisition by Google. And I mean, not Google Drive, sorry, Google Docs. They then proceeded to be the Google Drive leads at Google for managing that product. But they saw big problems at Google. And so they decided, these large scale data issues are things that we should do. So they actually did not move into a garage. They actually moved into Steve's attic and started Scalyr. So the mission essentially is to deliver the best event data cloud for real-time analytics, for for observability, and just pretty much use cases. So what is event data? Think about it as anything that happens, any stimuli produces an event. We want to be able to capture that. And really the only way for us to really use that data is if we can focus on sort of what we term the golden ratio, which is basically what is the point of creating data if you can't keep it and query it? And so really being able to afford it, and then and being able to adequately query it, you know, terabytes and petabytes of data is really what we focused on, because it just doesn't make sense to have data if you're not going to be able to make use of it. So that's really what our platform is focused on. And I love this slide. So Scalyr originally focused on observability. And so we have what you would expect of most observability platforms, where we integrate with microservices and tech challenges, basically, you know, integrate with clouds, and we pull that data in, you know, integrate with Logstash and Fluentd, and it all comes into our platform that consists of your search, your live tail, your materialized views for sort of a streaming analytics, and being able to start deriving answers from that data. And then on the right side, we also do third-party integrations. This Augmenting Elasticsearch being one of them. So, you know, being able to view that data in Grafana or Google Data Studio or Tableau is something we support as well. So I mentioned the golden ratio, and for Scalyr, really we are driven by this idea of that data should be affordable. At the end of the day, you know, most companies are either built on data, where they build their solution on event data, and for that we're a great solution for it. And then there's other solutions where people are not built on that event data, and it's more of, you know what, this is business intelligence that we're driving to, and we can use that data to make more money, but at the end of the day it becomes a line item, and you don't want to be in the business of having to consistently reevaluate your logging solutions because they cost you millions and millions of dollars. You know, so we want to be able to optimize that data as best as possible, and we want to be able to query that data as best as possible. So the way we do it is with this golden ratio, and we've engineered from the beginning to be aggressively multi-tenant. So what does that mean? You can imagine, you know, physical infrastructure, physical clusters partitioned per customer. And we've all probably worked for companies that have done this, where, you know, you create a solution, you get that one customer, you build it out, and then you need to go and build another one. So you go provision them a brand new cluster of something. And the challenge of that is that hardware sits idle. You know, you don't get economies of scale with that. And so we, from the very beginning, said, you know what, we are going to be aggressively multi-tenant. Everything is going to be one cohesive cluster. And of course, we have multiple clusters based on geolocations and privacy laws. But the point is that your data comes in, you get execution power of sort of that economy of scale, a pure cloud solution, to be to put it simply. A lot of what we do is built on this idea of trying to query the data less. And so we have built-in materialized views. We call those sort of our summaries, or our summary service. And it's all sort of becomes a bit transparent. So you can imagine data comes in, we have this materialized view. And so we automatically update that materialized view to keep it up to date. We evaluate alerts, and data goes off. And the same happens when you do a query. Data comes in. We basically see, can we speed this up by using summaries, and we query those summaries directly to be able to return results in milliseconds, as opposed to actually having to go and query the data. And finally, horizontal scheduling. This again is related a bit to the multi-tenant, but this is sort of a Google way of querying the data, where you know, when queries come in, we view them much like a serial queue, where query one comes in and we dedicate hundreds, thousands of machines all to that one query, and we can return results extremely quickly. And so, you know, what it means is that, you know, we get queries in, we return them as fast as possible, much like kind of how Google works, as opposed to, you know, these 5 machines are working on these queries, these 7 machines are working on another query, these 8 queries are working, you know, these 8 other servers are working on another query. And then by the way, these other 12 are going to spend the next 45 minutes trying to return one query. And that's kind of what we're visualizing here. And it's really just trying to be, you know, parallel run a whole bunch of queries, and it slows them all down at the end of the day. And so our point is let's optimize to get 100% CPU usage all the time. And so one other thing to point out here is that we do not use indexes. We focus on sort of those summary views and those to achieve acceleration, smart caching, you know, your query habits are data as well for us to be able to optimize moving forward. So introducing the Elasticsearch technology. Hopefully you joined a webinar on augmenting Elasticsearch, that these aren't super foreign. But we have, Beats, which is data collection. Scalyr has our own agents as well. But the idea here is you've already rolled these out to maybe hundreds of thousands of machines, and updating those, is disruptive. You already have a Logstash or maybe Fluentd or Kafka already in place to be able to feed data into Elasticsearch. And you already have Kabana infrastructure that is reading data. But if you notice, all those arrows are all pointing to Elasticsearch. And at the end of the day, typically where the grief starts or where the grief is on this Elasticsearch tier. And for smaller clusters, ones that are maybe dealing with a terabyte of data a day, usually no issue. But as these solutions grow, as they get multiple nodes, that's where really a lot of it focuses on. And so me personally, this was something I went through, and the solution that this was a focal point for me joining Scalyr. I was like, this is a problem that people have besides me, and I think we should solve it. And so this was really kind of my focus, was building it. So where does Elasticsearch go wrong? I just wanted to give, and this is some of this is going to be a bit of opinion, some of this is going to be sort of looking to the future, but the problem is that Elasticsearch does have some challenges that are there. And so one of the chief challenges that I see is, and this sounds strange, is data nodes. You're like, well, wait a minute, data nodes, what are you going to use in its place? And the problem is not necessarily data nodes. The problem is that data nodes have storage, and you basically have to do, once something lives on a data node, and data nodes have Elasticsearch versions, so they need to be upgraded. They have, when something goes wrong with those data nodes, they need to move data around in the cluster. And so to be able to have more storage, you have to have more data nodes at the end of the day. And the challenge is that, compute and storage are tragically linked. In Scalyr, we're object store backed. You can think of us as, being able to read the data when it's needed, optimize the data as it comes in. And really, with these nodes with these data nodes, data always feels like it's moving around in the cluster. It's always in flight, either due to some sort of fluidity in the cluster, adding new nodes, doing something else. It's always rebalancing, it's always moving around. So this was something that I personally experienced, just watching data move around, and you're just like, stop moving around. I want you to do work. I want you to answer questions, not just be in this constant state of flux. The other one is indexing in general. So I will say that I am not anti-indexing. I will say that I am anti-indexing when speed matters. And it took me joining Scalyr to really kind of grasp what this was, because the reality is most of us think indexing, well, that's the only way to do it. And the reality is that there are other engineering ways to solve this problem. But indexing adds its own challenges as well. Indexing bloats the storage requirements. Indexing requires an awful lot of CPU for events that are coming in super fast. And so you end up with this sort of, almost like a thundering herd problem, to where, great, now I've had, 1,000 events works great. You don't notice anything. And then all of a sudden it's 100,000 events, and your CPU demands, your write demands, all of those all go up. And it really creates this challenge of being able to, keep up with a real-time demand. The other one, and it's funny because I was a schema on, everybody started with schema on read, and then everybody's like, schema on write is the answer. And the reality is I actually don't necessarily believe schema on write is the right answer for data that is, for these sort of big data. And the reason is, and I see, everybody's probably going, why would I dare change? The problem with schema on write is that you need to get it right, or else, it's the idea of these rigid schemas that we're going to create and we're going to write once and we're never going to have to touch them. It's not true. You can see it in Elasticsearch, as well, where they created their standard schema, but even that standard schema keeps changing. And every time a field changes, you're just like, it becomes sort of this dead of, well, if I want to query that data, then I need to have this magic formula. And then, oh, we go backwards and we don't get answers. And so for me, there needs to be something in the middle between schema on write and schema on read. So, we still optimize on write, of course, but then we also need to have that flexibility to be able to really just run and figure out any question we have on the data. So a bit more of schema on read. And so marrying those two together has been something that Scalyr has focused on. And so in our land, you can go and run a complicated regex to derive some metric. And then you put that onto a dashboard, and we have talked about materialized views. We will actually go and optimize that data from the beginning of time so that you can query and ask that question repetitively for forever. So, and then as new data comes in, we also optimize that data as well. So it's a bit of schema on the fly, if you would, and schema going back in time. And so it works really well. And so, but the point is schema on write, the amount of times that I've gotten, a string written where it should have been a number, it's been, or data loss because somebody went and changed a format. They fixed a bug, they changed that string into a number, and now we have data loss for X hours because the schema is expecting a string and they're writing a number. So again, rigid schemas for me is just a bad call, because we don't need rigidity. We need flexibility. We need something that makes us better as engineers, not constantly tells us how we've messed up by fixing a bug. So the challenge really starts in sort of this rinse, wash, repeat, constant churn of Elasticsearch world. And I'll give my darkest day of Elasticsearch in just a second, but I wanted to first describe the process. So you start out with an Elasticsearch cluster. You've installed it. Maybe this started as a small POC, or maybe it was a huge project. The point is you usually start pretty simply with a small cluster. And most engineers would wire up some sort of ingest for this, Logstash, Fluentd, Kafka. And then you go and you find your data and you start building in event data sources coming in, and you start putting data into it. And then a funny thing happens, and is that at some point, data starts backing up. Hopefully you've got a queue here so that you don't lose messages, but if you don't, then this is just data loss, but messages start backing up. And then you as an engineer, or you as the operator, you go and you look and you say, well, what happened? And you realize that, oh, you ran out of space, or, oh, you lost a node, or, oh, the velocity of events coming in is just too great for this cluster to handle. And so most engineers will just add new data nodes, and the problem goes away. And the problem goes away until it doesn't. It'll eventually come back. And this is this sort of cycle of challenges going in there. And it's not just one variable. It ends up being several variables that you're tuning that are hard. And especially this even gets worse as the more people and more data sources you coming in, because they end up being just sort of different workloads, different challenges of different data requires different amounts of CPU and different storage requirements. And so, so you add more nodes because that's the easy one. It's kind of like the Java world, you just get bigger hardware, you add more nodes, and then the problem does go away. And then, we end up with just this sort of vicious cycle of adding nodes. And I remember starting with like 6 nodes and, and remembering when I hit 20 nodes, and remembering when I hit 30 nodes, remember when I hit 60 nodes. And then at some point you start going, this is getting a little ridiculous. And the worst happens is, when you don't feel comfortable adding nodes, maybe a boss has come over and said, this is costing too much. And so you start deleting data. You sit here and say, well, we started out with this optimistic 45 days of retention, and yeah, but we're going to have 12 days. I remember on one of my Elasticsearch deployments that I had 4 days worth of data. And I'll be honest, I felt embarrassed. I'd hit a scaling limit with the version I was on, and there was just nothing I could do except remove nodes at the time. And so, I got past those. I added retention back. But then I ended up, and had a huge cluster, but then you end up in constant recovery. As you add nodes, data goes down, one of them will go down. And the challenge with that is as soon as those nodes go down, then the cluster ends up in a sort of a state of, oh my, we've got to protect the data. And then basically distributing that data ends up being a priority for the cluster. And what ends up happening is that cluster is spending a lot of time recovering. It's spending a lot of time ingesting the same amount of data, and it's spending a lot of time still servicing reads, your actual, your actual service delivery of answering questions. And so data starts to back up again. And so it really, clusters eventually end up in this sort of red status, which ends up being sort of a total down, or data is not, you can't write to a shard. And that ends up being sleepless nights. And then ultimately, the biggest issue is that the business ends up getting a lack of confidence in the solution, because either the dashboards aren't available, the data is either behind, or it's not, or it's just crashing in some way, or the business just doesn't trust it. Maybe you have schemas that are losing it. But the point is that you end up in this constant churn of having to babysit these solutions. And I was in, I mentioned I was going to tell a story. And so my darkest day was a bit funny, is talking about lack of confidence, is I spoke at one of the Elasticon events, and I was just about to get up on stage. And then I got a notice saying that the beastly Elasticsearch cluster was down. And I'm sitting here kind of, troubleshooting in one hand, trying to do what I can. And of course, these recoveries take, aren't measured in seconds. They're measured in minutes, hours, not days typically, but the point is that the cluster was down. My customers were not being serviced. And I then get up on stage and talk about how Elasticsearch is going to solve other engineering problems, not necessarily, but the durability problem was not one that was in my presentation specifically. But the point is I'm getting up on here, literally thought leading on Elasticsearch, saying this is your solution. And the reality is that it was also letting me down. And so that was probably when I personally lost confidence. I believe the business had already lost confidence way before that one. So the point is, this is not a fun cycle to be in. Nobody wants to be in this cycle. And so when I came to Scalyr, this was one of my chief goals. And there are other solutions out there that talk about keeping Kabana, but the reality is that they don't actually let you keep your Kabana. And so, what's the point of having some extra Kabana that is specialized, that is special? At the end of the day, I wanted to keep my Kabana. I want to be able to keep my Logstash, honestly, because I've already invested all that time in there. It's already done. And so what I wanted to focus on was, can I put the data somewhere else? And in this case, the data goes to Scalyr. Can I maintain my existing infrastructure? And would there be a way for me to bridge those two worlds? And so I'm happy to say that I was successful, that we have this Elasticsearch, the Scalyr Elasticsearch connector that essentially sits as a middleman that takes in Elasticsearch queries, returns results using Remote Cluster API, and then basically issues those translated queries and results to Scalyr. And so, what this does is this means that Elasticsearch cluster on the right doesn't have to have those data nodes added. It doesn't, those go away. And here to kind of demonstrate the concept is, very similar graph. This is our challenged infrastructure. We've been organically adding nodes to the point where we're just, have an out of control bill, out of control number of instances to control, upgrade. And so the goal is, let's take that ingest and let's plug data directly into Scalyr. The Elasticsearch is much reduced. And then the ingest goes away. I mean, Scalyr's ingest is built for 200 plus terabytes a day. I mean, we've scaled it up way beyond that as well. And that's per customer. And so, those are scales that very few companies are dealing with. And we know we can go way higher. Steve, who wrote Google Docs, when we were doing the super duper scale test, was basically like, yeah, it's not even breathing hard. And so the ingest problems really come from the fact that Elasticsearch is trying to do too much with each event, and trying to ingest those and trying to index them into basically hardware of magnetic disks that are sitting there is just too heavy. And so the point is, the Scalyr is ready to take that off your hands. And then the only thing we need to do then is just to bridge the two worlds. And that's where this Elasticsearch connector comes into play, where we can basically translate between the two worlds. And you would still, in this scenario, you would still keep a small Elasticsearch cluster. There may be data sets that you may not want coming to Scalyr, or there may be data sets that are, you may want that flexibility of being able to determine which goes where. And we get that. The whole point is that you can keep your Kabana, you can keep your custom applications, and we can take the majority of the grief by taking these writes. All the writes can be offloaded to Scalyr. We've already mentioned that it's a bridge to the Elastic land. The idea, though, is your sleepless nights are gone. And because Scalyr specifically is built for this high velocity of ingesting data, durability, and, we're really, really good with our uptimes, really good with being able to index our data. A lot of these challenges of data is backing up, a lot of the challenges of having to scale infrastructure, like it's all handled on us. But we're really, really good at it because this is what we do. And so ultimately the business gets more durability, and confidence increases. You get more, you can ask more questions of the data, you can get more answers, and honestly, you can go and do other things that the business needs. So I do have a demo, and this is a complicated demo because there's a lot going on here. But I ultimately want to be able to load data into an Elasticsearch. For me, the demo here, and I don't think it's a good webinar without a demo, is really just to keep me honest. And so we'll load data up, we'll analyze the data, and this will be just using Elasticsearch technologies. And then we'll load the same data into Scalyr, and then we'll configure and view the data in Kabana. And so we'll get started. These are video presentations because trying to do all this in real time with a webinar going, you can take that challenge. I will not. So we start out with a blank Kabana. That's not a blank Kabana. Let's see where we end up. There we go. Good. So we end up with a blank Kabana. So I will actually query the indices here and just show I just started this up. This is 6.2 on purpose. One of our first big initiatives is around 6.2. This was actually developed on 7.8. We will actually we'll actually load some data in. So data is going basically to a local Elasticsearch. I'm not going to build a 40 node cluster for you to see from static data. And then we're just using a field in the data for where our index goes. And the data set we're using is the Kabana sample data set. We felt it was really important to be able to show the data set that is one that Elasticsearch shows. And we're just running this as a Docker container. So there's no magic here. This Logstash is just going to run load data into Kabana. Load data into Elasticsearch. And of course, these things don't take milliseconds to run, but we will save ourselves some time. So here is some data loaded. It's not a lot of data on purpose. This is a demo. And we can just make sure, we have 5,381 documents, so it's not a huge data set. But the point is that we have this Kabana sample data set loaded. And so, typical, this, you want to be able to create an index pattern here. This is basically just a configuration in Kabana to allow you to view that data, and you index by a timestamp. And then, you've loaded the data up, and general use case is, oh, gee, I've got data. And now you can start seeing it. This data is a little bit old, so we go back in time for it. And there's our 5,381 events. It's actually less events than that, but and you can see here's all our fields parsed. We use codec equals JSON. And I'll go ahead and, like I said, keeping us honest, I'll go ahead and just show us creating a couple graphs and what they look like. And so here's the events mapped over a time series. And then we'll just save that one just for posterity. And then we'll also go ahead and create my favorite visualization, which is just pie graphs. And so especially on time series data, just allows you to bucket time series data together in a way that you can visualize, visualize and see, relationships in data. Single tier, that's no fun. We want to be able to go multi-tiers deep. And so this was sort of the, is it going to work? Early in my prototype a few months back was, can I make this work? And that's exactly the wrong field. And so I was happy to say that this was actually because of the Scalyr platform and the way that was designed, this was actually something that wasn't as nearly as difficult as expected. And so we visualized sort of a 2-layer pie graph. I will say that things get challenging in Elasticsearch when you go 4 or 5 deep. Because of the design of Scalyr, it's not really as bad. It's not really as bad, which is interesting, because we don't use indexes, and you would think that there would be some challenging. So that gets us our sort of baseline. We have an Elasticsearch cluster. We have a Kabana data. We have this Kabana sample data set loaded, and we've just created some visualizations just so that we can see. And so let's see if we can. There we go. And apparently, I need to. There we go. Okay. So now our goal is to load data into Scalyr. So we'll go back to that Logstash, and we'll go back to that Logstash data set, and we'll, I've been playing around with some of these. And so we have our Scalyr only, which is really just about the same thing. The difference is we use our Scalyr Logstash plugin. We write to a Scalyr endpoint. We still use that same logs.json. We are not tied to JSON data. We can take data from anywhere and we can parse it. And so we do need to give a hint to our backend, just say, hey, this is, parse it using our Logstash parser, which is really just doing a JSON parse. And then we get to run it. Didn't change much here. And we get to run it, and we get to load data into Scalyr. And so here's the data load into Scalyr. Of course, this took more than a millisecond, and you'll see that we have the 5,381 events there. And if you go down, we end up with the same fields that you would expect, that you saw parsed in Elasticsearch. So there's, the engines are there. All I've done is really swapped out for a stronger, more scalable engine. And so now we need to bridge these two worlds, and that's where our connector comes in. And to keep things simple, I've put this into a Docker Compose file. There's some configurations here. Specifically, the one that matters is our Scalyr index key. And so Scalyr itself is think of it as a ginormous store, and we have attributes. And to map them into sort of index land, we kind of need to give a hint onto what we're going to use for an index. And so basically, all the values of the Scalyr index key is going to become our indexes. And so the only value we have in there right now is Kabana sample data. And that came from the event. And so if you're mapping in data into Scalyr, if you don't have the index key in the event, that would be one thing you'd want to add. And so we've actually, now that we have it up, we have our local Kabana sample data set, and then we need to just configure remote clustering to be able to attach to this Scalyr Docker container. So that's really just an endpoint, using the transport protocol of Elasticsearch, and we can configure that one, and then we can start querying it. So the default search doesn't return much. But the point was to make sure that that was successful. And so we go ahead and we can create an index pattern. And so in remote cluster, there is a prefix here. And so you can see Scalyr : star, and all of a sudden Kabana sample data logs shows up. And so, we query that one. We can see that there's a timestamp in the field. Not at timestamp, but that is something that we are, I would not be surprised is added later this afternoon to be able to have a simple alias there, just to make that parity between the two solutions there. And then we go ahead and create the index pattern. You see that it has the same fields, strings are strings, numbers are numbers. And here with, an interesting Kabana bug, this is 6.2, where it didn't want to let me dive into this one. So you will see me go back to go ahead and set ours as the default. And this is just demo things of moving some things around to give you a consistent feel. So we go ahead and we set this as the default index pattern. And then we come in here and, more data in there than the other one because this was a demo and we were doing some work, but you'll see that we start having, data showing up as you'd expect. And the question is does it visualize? And maybe the $1 million question for some. And so we go in here and we do the area, and just to keep, like I said, keep us honest, we can go ahead and add the date histogram, verify that data does come up. And this is a little bit zoomed out than where we originally started. So there's a little bit more clarity here. And so of course the payoff here is, does the multi-slice work? And that was a rhetorical question because of course it works. It wouldn't be in the demo if it didn't. And so so the thing here is that, I don't in this demo show us using the same graphs that we created earlier. That is something that we definitely can support. The timestamp, there's a couple things that obviously we need to make sure that are there, such as the timestamp. But these are all small changes. The reality is that we should be able to use the exact same visualizations just by going and modifying those index patterns. And we actually have a script to modify those to roll them back for you, so that you can kind of test this out in a kind of a no risk scenario. You want to put some data into Scalyr, at 1 in the morning, and then go and change your index patterns to see if the graphs still look good, and then switch it back. Want to be able to query both data sources and reduce them in Elasticsearch, and then have a cohesive view. All of that works, has been tested in our setup. So let's see, there we go. So takeaways, besides the free kittens that everybody was sent for signing up, is that Scalyr is ready to help. And the reason we're ready to help is because this is something I personally have experienced. It's something that I personally brought to Scalyr as a perspective, and honestly, it was a solution that was needed. Ingest issues for these large data pipelines are real, and having a provider who is able to scale and meet millions of sessions. We have people using IoT devices, funneling into our back end. We have super large e-commerce customers using us. The point is that we are ready to handle ingest issues and get rid of those delays. Solve the scaling issues. Who wants to be up at, I personally was up, remember being up at 2 in the morning, pulling an all-nighter, trying to get, the cluster back up, or trying to add nodes and praying that data came, got fixed before other people woke up. And so nobody wants to be in those sleepless nights working on scaling issues. And honestly, nobody wants the business sitting here telling you that they don't trust the solution you've engineered. And so at the end of the day, Scalyr is, was built to solve these problems, and the experience comes from Google. The experience comes from me with my experiences with Elasticsearch. And we have a lot of that experience. We're here to help you. And also at the end of the day, we'll probably save you a lot of time, and we'll also probably save you a lot of money as well, because like I said, our golden ratio of cost, performance, and scalability, cost is something we really focus on. So that is all that I have for now. I will hand this back over to Neil to close us out, and perhaps we can look at questions if that is, if there are any.
Thanks, Anthony. So as we draw to a close here, one of the things I think worth mentioning is that we are in our early access with our Elasticsearch connector. And so there are a couple of things I think we can do from here. The first is, if you have any questions, feel free to reach out to either Anthony or myself. Our email addresses are here. But equally important, as we continue to develop, and we are a company of engineers who build for engineers, and one of the things that we find super helpful is when we take direction from customers who are dealing with certain issues, and often come across something that say, I wish I had this and I wish I had it today. And we're in a constant journey of actually building out the features and capabilities that engineers want. So it's a critical thing for us to take feedback and work very closely and partner with some of the customers that we deal with. So if you have two things that you can do here, one is if you want to ask some questions, feel free. And the second thing is if you have some suggestions, it's a great opportunity to send some stuff to Anthony and myself. We do have one question. Let me just go here.
Yeah, I'll let you read it because I'm not touching anything. Everything's perfect right now. So what you got, Neil?
Yeah, so we have one question, Anthony, which is, it says, nice talk. So thank you for that. What sort of advanced Lucene aggregations or functions are not supported yet?
Yeah, this is a good question. So we're, one thing that we will not support is like sort of term scoring. So the scoring things are not supported. We have a we are supporting max, min, sum, standard deviation, and the engineer who's working on this is is like, I should just go ahead and add these because they're right there. And so the reality is we built I started out with a POC, built something that was functional, and I'm humble enough to know that I don't write great code. And we've since handed off to a brilliant set of engineers, and the lead engineer on this, who's absolutely brilliant, basically just adds these things almost in his sleep. So I would say that the scoring, scoring of documents is probably something we will not support, because there is a parity mismatch between what Scalyr does. But most of the other aggregations are either already supported or are already there. It's not a great answer to the question. I don't have the list in front of me, but the ones you'd expect of standard deviation, sum, max, average, min and max, those are all pretty accessible. And the other ones we could, I think we should definitely follow up. Shoot me an email if you have any in particular. I can also produce sort of a delta, and we can take it offline.
Perfect. Thank you, Anthony. Well, I think that about wraps it up for now. So thank you all for attending. And Anthony, thank you for taking us through. There was, I think, a great summary of the things that we're doing and innovating in the space of how we help customers really reduce the overhead. And also, like you were saying, is, get that golden triangle of reducing price, getting context, and then also this massive scalability. So thank you very much for sharing that.
Definitely. Thanks everyone for joining, and I'm looking forward to speaking with all of you in the future. You guys take care.